Yes. So we are doing cengage book daily practice problems 4.3, which is motion with constant acceleration. This is the section of problems which actually uses those formulas which we actually derived till now. What are the three formulas which we derived in 9th standard? V is equals to U plus AT. S is equal to UT
UT
plus
plus half AT square.
half AT square. And the third formula was V square minus U square is equal to 2AS. If you observe these three formulae, acceleration is a constant in all of these formulas. The acceleration is constant. Without the acceleration being constant, these formulas are not holding good at all. Understood? Of course, there is a fourth equation of motion which you know, which is ascent is equals to, which is not a new formula. This is a derived formula from the second equation, which is U plus A into n minus half.
And
In
minus
all
half.
these formulae, acceleration is constant. That means, what does that mean? When acceleration is constant, the displacement, if you observe this equation number 2, displacement equation, what you observe is it is ut plus half at square. Now, please pay attention to this formula carefully. It looks something like at, A is the u, A is a constant, and this whole half A is there. No? That is some constant B T square, AT plus BT square. This is like AT plus BT square. Any equation which has a quadratic variable is said to be a parabolic equation. This parabola, it's a parabolic equation. So if you plot time on the x-axis and displacement on y-axis, what are you eventually going to get? This is what you're going to get. From here, it will start like a parabola and go up like that. Why will it start from this point? Why not start from origin? That is because there is an AT term. If this AT linear term was not there, then it would have started from here only. It would have started like
Yes,
this.
sir.
Okay. Remember, any equation which is having a proportionality in quadratic thing, any quadratic variable and proportional to the quadratic variable is said to be a parabolic equation. So this displacement is a parabola. Only thing, this linear, extra linear term, what does that contribute to? That contribute to this it starts from AT. It starts from AT. This extra on the y-axis is only AT. Plus this term, the parabolic term, is BT square. Now you must get it out. Sir, parabola means this side also something should exist, no? On the negative side also. Parabola, when I told you about parabola, I told you parabolas look like this. Is it or not? Yes?
Yes, sir.
Then why
Yes,
this
sir.
parabola doesn't have anything on the other side of the y-axis? Can you tell me?
Sir, it's out of the graph, sir.
What is it? It's out of the graph. What is that answer?
Means we only draw two axes, no, sir. Means
No.
not.
You
X
are
cannot be negative, sir.
time cannot be negative, no. There
Okay, sir.
cannot be
Okay.
a time negative, is it or not?
Yes,
Yes,
sir.
sir.
Yes.
There is no negative time. That's why you cannot plot any graph this side. Time is
Okay.
always positive. Is it or not? That is why the
Yes,
graph
sir.
is only on the this side, the first quadrant only. There is no graph on the second quadrant. Actually, parabola should have two quadrants.
Yes,
Parabola,
sir.
general parabola looks like this. Okay? Generally, this is how the parabola will look like, or this is how the parabola will look like. That is because those parabolas have x and y. Or here, if it is -1, here if it is +1, then there is a corresponding -1 on this axis also. But time cannot have a negative time, right? Did you understand?
Yes, sir.
Yes, sir.
That is the reason there is no parabola this side. This can be asked as an assertion and reason question in IIT JEE. Okay, so you should understand.
Yes, sir.
Remember why there is no parabolic, there is no symmetric parabolic graph on the other side of the y-axis. Why? because time doesn't have. There is no such thing, something like minus time. Is it or not? Is it understood?
Yes, sir.
Yes, sir.
You can note that if you want.
1 minute, sir.
Is we are going to use these formulae and do solve these problems motion with constant acceleration. Now you must get it out about those problems which you already did in the daily practice problems 4.1 and 2. In those, did you observe acceleration was not a constant? Is it or not? The acceleration was not necessarily a constant, because sometimes we have got acceleration being proportional to time also there. But here we will not get such a proportionality. Time, it is always acceleration is some number like 2, 3, 4 with a unit, of course, meter per second square or kilometer per hour square. That is a rare quantity. We'll never get, we very hardly get kmph. Okay, we always get kmph square. We hardly get this unit. We always get the meter per second square only. Okay. Yes. So now we are going to start solving these problems. Okay. First, there are several problems in this. There are only 12 problems in this daily practice section 4.3. I'm going to solve those which are big, at least which they look big. I'm going to solve the second problem now. Okay. Because it's a subjective question. A driver having a definite reaction time. What is reaction time? Now, first you should know what is reaction time. Reaction time means, in your IPE book also this concept is there, reaction time. This is an experiment that everybody should do with themselves to know how good is your reaction time. Reaction time is basically, for that you need to see the video, then only you will understand what is reaction time.
Yes, sir.
Now coming back to the reaction time that he is speaking in this this thing. Now I have explained you a concept of IPE also. You can check your IPE textbook if it is there with you. What I told you right now is there in your IPE textbook. I'll just finish that IPE thing also. In your IPE textbook, what is written is S is equal to UT plus half AT square. They use this formula and they said reaction time we have to find out for you. So what they said, S we know. What is the S is in that, in your textbook it is given, the person could hold back the 30-meter scale at 21 centimeters. Okay, this is there in your textbook. And what was the initial velocity of the scale? 0. Is it or not? 0 into
Yes,
t
sir.
plus half. What is the acceleration with which the scale is falling down? Gravitational acceleration. Is it or not? That is simply
Yes, sir.
nothing but 9.8. We don't know your reaction time t. Then in your textbook, what they have done is, what would you get? Tell me. 2 into 21 centimeters divided by 9.8. Is it or not? The root of this, what? This is what you will get as your reaction time. Is it
Yes,
understood?
sir.
This point?
Yes, sir.
Yes, sir.
This is there in your textbook. I'm telling you from your IPE textbook. But mind it, this is centimeter and this is meter per second square. Is it or not?
Yes, sir.
Centimeter
Yes, sir.
is converted into meter, 10 power minus 2. Now, if you do all this, what you are going to get, I am telling you, 0.21 seconds. If your reaction time is less than this, you are the most intelligent person in this world. You must be Elon Musk or you must be Einstein. Sachin Tendulkar's reaction time is very fast. His reaction time is less than 21, less than 0.21. It seems it is like 0.19, something like that. Why? How could I know that? In the 1990, some 2000 something, there was a World Cup. You remember? In that World
Yes,
Cup,
sir.
the fastest ball in the history of cricket was bowled by Shoaib Akhtar with like something, I don't remember that numbers, some 300 kmph or something, and Sachin Tendulkar could hit that ball with a very fastest reaction time, which is far lesser than average human beings. So that is how they came to know that his reaction time is very fast. Okay, so you should test your reaction time also today. If you are able to hold it at 30 centimeter here, then your reaction time will be more, is it or not? Yes.
Yes, sir.
If you are able to hold it at 15 or 16, then your reaction time will be very less. Did you understand? Is it clear?
Yes, sir.
Now coming
Yes,
back
sir.
to the reaction time of this person who is driving the vehicle. What is the meaning of reaction time for this numerical? I'm telling you that now. Okay. You want to copy this?
1 minute, sir.
Sir, can you say the definition, sir, of reaction
Yeah,
time?
I will tell you. Now, what is the reaction time concept while a driver is driving a truck or something? If you are ever driving something, this you would also know.
Sir, let
Generally,
me explain.
braking thing. You apply brakes, no? You
Yes,
see
sir.
some
Yes,
object
sir.
or somebody in you don't topple and go on them, is it or not? You see an
Yes, sir.
object or person in the way of the road, then what would you do? You will brake,
Break.
is it or not? The time
Yes.
difference between you seeing the person and the time at which you applied the brakes, this is his reaction time. Understood or not?
Yes, sir.
Yes,
You
sir.
saw the person, he is in front of your bus, then what would you do? Will you just wait and see, let me go over him and then we'll apply the brakes? Would you do that? No. At 21 centimeter, probably at 21 meters, not 21 centimeter, 21 meters, you saw the object or person. What would you do? You'll apply the brakes. Is it or not? That is your reaction time. Is it clear to you?
Yes, sir.
Yes,
Reaction
sir.
time means what? Now,
Yes, sir.
driver having a definite reaction time is capable of stopping his car over a distance of, means this is called as stopping distance. This is called as S but subscript stopping distance. What is stopping distance means? If you apply the brakes here, what happens? It will not stop there itself. It's not disc brake, is it or not? He applies the brake here, it stops here. It just stops before the person. So that is called stopping distance. At the stopping distance, its final velocity is 0. He would have got an initial velocity which is non-zero. Understood that? Now, what is the stopping distance in this question he has given? 30 meters. Okay, on seeing a red signal. So there is a red signal. I'm assuming there is a red light or red signal, something like that. When the speed of the car is 72 kmph. 72 kmph means here originally his speed was 72 kmph, means you have to convert that into meter per second. I hope you know that. Then it will be 4 times. 4 5s are 20 meters per second. First convert that. This is u1. Initial, when his initial velocity was 20, he could stop at 30 meters. Is this understood? Then the next
Yes, sir.
situation. This is situation 1. Next, second situation is, again he is seeing the red light, but now he is able to stop at 10 meters only when his truck is going with a initial velocity. Now something else is the initial velocity, 36 kmph. So what we have to do, again convert 36 into 5 by 18. Both of you know this conversion, right?
Yes, sir.
Yes, sir.
So it is 10 meters per second. This was a U2. Then this is what? S2. And this is why S1. Okay. And V is anyway 0. No need to worry about that. V1, V2 both are 0 because it is stopping. Okay. Yes. So find the distance over which he can stop the car if he were running. This is third. Third situation is your questioning situation. Third situation is when the car was traveling with a velocity of 54 kmph. Again convert that, 5 by 18. This is 3 times. So it is 15 meters per second. If this was his velocity, what would be his S3? Understood the question clearly? How to
Yes, sir.
solve this problem? We are not given acceleration, is it or not? Which is nothing but the retardation, is it or not? It is minus A, which is common for all of these. Okay, all the situation 1, situation 2, situation 3, retardation is common. Okay, that is not changing. That is the only thing which is not changing. Is it understood? Using that, which formula will hold good to solve this type of this numerical? Let us comprehend. U is given, V is given, S is given, and A is not given, but it is constant. So which formula holds good? Which holds U, V, A and S? The third equation of motion. Did you get it? Okay.
Yes, sir.
Third equation of motion. Have you copied this? Now coming back to the numerical, which formula holds good for us? The formula number 3 of kinematics, because that is the only formula which relates final velocity, initial velocity, acceleration and distance or displacement. So this is the formula which we are going to use, the formula number 3 or equation number 3. In all the three situations, we are going to use the three situations. All the three situations, one thing is for sure. V1, the final velocity. V2, the final velocity. V3, the final velocity are 0. No doubt about it. Because it has to
Yes, sir.
stop. So let us write the formulae. 0 square. First situation I am using now, situation 1. Minus u1 square is equal to 2. Here I will write instead of a minus a into what is s here, s1. S1 is how much? I will write s1 only and later I will substitute. Okay. Now apply. Now substitute. Minus 20 square is equal to minus 2a. S1 is 30. Okay. No problem. Let it be. Okay. Cut. Cut. Okay. This is the first equation. Okay. Similarly, can you tell me the second equation? 0 square using this data. 0
Yes, sir.
square minus u2 square is equal to minus 2as2. What would that be? Fatafat, tell me.
0
Minus,
square minus
uh,
225.
wait a minute. Minus 10 square. This is 10, no? u2 is 10.
15, sir.
u2 is 10. Check this. What is u2?
Yes, sir. Yes.
10 meters, sir.
Is equal to
Yes.
minus 2a. S2 is how much? 10.
Yes.
Yes, sir.
This is your second equation.
Yes, sir.
This
Yes,
is my
sir.
equation number A. This is my equation number B. Before the time finishes, please write that.
2a equals 10, sir.
Just before 2 minutes, we'll stop. We'll stop and again re-click it. Okay.
Yes, sir.
Yes, sir.
So now that is like the third equation. Third equation of motion. Third equation using the data, the questioning data. What is the third equation? Please tell me.
Sir, we can simplify the second equation.
No, that's what I'm telling. Don't simplify. Why no? Why we should not simplify? I'll tell you. If you simplify, it will not be that easy. Yes, of course you can simplify. Without simplifying only we can do it. Okay. What is the third equation? Third, which is third. Here. 15 square. Is it or not? Minus
Yes,
of
sir.
15 square is equal to, I'm writing it directly. I hope you know. Minus 2a
S.
s3. We don't know that. Is it or not? This is
Yes,
the thing
sir.
which we want to find out. Is it or not? But of course we also have to find out the acceleration. Is it or not?
Yes, sir.
If we find the
Yes, sir.
acceleration, we can substitute it here and get the answer. That's it. Understood?
Yes, sir. Yes,
Yes,
sir. Yes, sir.
Yeah. I hope you understood what to do.
Simplifying the equation, we get
Yes,
A is
sir.
equal to this
Yeah.
much, sir. Like,
In any of the equation number 1 or 2, you use it and find the acceleration.
yes, sir.
Can you do it?
Yes, sir. Yes, sir.
Come on, try. Got the acceleration
5, sir. 5, sir.
from the first equation.
Yes, sir. No, sir. From the second equation, I got 5, sir.